Can you hear me now?
Yeah, I can hear.
Now you can hear me, right? So I think with headset it's possible. Yeah, I think you can start now. And also, if you can send me your account details, I will pay the money. Okay,
Yeah, yeah,
I'll transfer the money. Okay. Is it okay if I transfer it tomorrow morning?
yeah, not a problem.
Right? Okay, fine. Can you
If
just
you
give me a
say,
quick overview about what is neural network, right?
oh, fine. What is machine learning? How all the algorithm works?
Yes, yes, I know that.
Okay. So, an advanced concept of machine learning comes in neural networks. So, neural networks was developed on depicting the human brain, how this human brain works. So, it's a kind of biological and scientifical and this computer field brought into one, and it's been generated as a neural networks. So it will have many neurons, and each neuron will be connected to another neurons with some weightage. As the neurons goes by different layers, it is called deep neural networks. It is called deep learning. Okay,
Okay, in
and
between the input and output layer, if you have multiple in the hidden layer,
hidden
right? So
layers.
that's what your
Yeah,
deep neural
yeah,
network. Okay,
yeah. If you have more hidden layers, that's called deep learning,
okay.
deep neural networks.
Mhm.
So the connection between a layer and another layer will be there with the weightage will be there, so that so it will keep on adding
So
some
how the
weightage.
weightage weights are calculated? Any idea?
So on initially it will be random,
Okay,
and it will back propagate on seeing the result. If the result is wrong, so definitely on the first iteration it will be wrong, right? So it needs to adjust this neuron output based on their weightage. So it will back propagate to uh, the hidden layer on last hidden layer, and it will do some. There are mathematical calculation over there using integral and differential calculus. It will be uh, uh,
okay.
accumulating
In
the
R,
weight.
I have seen it. I've used nnet package. Okay, nnet function. So there,
Yeah.
back propagate, an option is there. So in order for the to use back propagation, do I need to enable it or is it a default behavior?
No, it's a default behavior. It's a back propagation default. So
But there is an
it will be
option
back.
in R to enable back prop. If I don't do that, it will be feed forward. I think so.
Yeah, it's a feed forward. So you can keep on building multiple near layers. But if on the first try, on the first iteration, you can't have better result. It's an obvious. So if you do back propagation, your prediction will be good.
Okay.
Okay. Without
So what
doing
you're
back
saying is
propagation,
if I use multiple iteration, iter option is there. If I use iter operation, using it'll do back propagation and it'll try to optimize the weights for each
yes,
neuron, right? Okay.
yes, exactly. There are many such ideal definitions there. Iteration is one such definition. Then epoch is there, batch is there. We need to understand everything. Okay, so iteration is not same as batch. Batch is not same as epoch.
Okay. What is the difference
Okay,
between batch and epoch? Epoch is an iteration, right?
so batch is if you have 10,000 data, 10,000 rows, so you'll be sending with a batch of 100 data. Example, so send this 100 data at a time. So I can't send 1,000 data at a time. So batch by batch send, that is called batch size. So if I have 10,000 data, send the batch size of 100. So for each 100 will be going one by one, and for each batch how many iterations should do, that's called epoch.
What is it?
Okay,
Can you come back with
and
epoch for each iteration?
for each batch how many times I should iterate, that is called epoch.
Okay.
Okay, and for sorry uh, sorry, that is for iteration. Okay, and for all the data set how many times I should go on, that is called epoch. Okay, clear? For all the data set I have, if I have 10,000 data set, how many times I should repeat, how much I should iterate, that is called epoch.
So why
And for
it has
batch,
to iterate? See, I have 10,000 records, and if I use epoch is equal to let's say 10, so why it has to
yeah,
iterate 10 times with the same data?
yes, exactly.
No, why does it require iteration for the
No,
10,000 records 10 times?
no. If I why means so if you want to do more iteration, you will get good better result. You can check on each iteration what is your prediction. So
No, you mean
on
to
first
say it will sample different set of data from existing data, or see, data
that
remains
is
same,
batch.
isn't it?
Yeah, that is batch. So if you want a batch size, that is different.
No, I'm
For
not talking
example,
about
as per
batch. I'm talking about iterate. Okay, so sorry, epoch. Epoch is to iterate, right? Let's epoch is equal to 10. 10 time it will
yeah,
iterate. So what you're saying is back propagation will be applied 10 times, and then
yeah,
it will try to minimum optimize the weight. Is that what you're saying?
yes, exactly.
Okay.
Okay, so got the point what I'm telling. Any doubts?
No, nothing. Yeah, go ahead. Yeah.
Fine. So that's back propagation and how this mathematical calculation works. You need to research on more on things. Okay, mathematical.
Okay.
Fine. Let us go on convolution neural networks. So convolution neural networks is one such type of neural networks architecture which does better in images.
Mm-hmm.
Okay, if there is an image is there, so how to classify an image or how to recognize an image.
Mm-hmm.
So that where scientists has come up with the neural networks called convolution neural networks. So it is good for doing 2D data, that is 2D image data with black and white or RGB data. Anything it can handle well. So what is the primary goal or primary objective of creating this convolutional networks? So again it depends upon the human perspective. So when a human is seeing any image, so if you see this slide, so you will be concentrating on this data, right? So this data. So
Yeah.
you won't be concentrating on here or here or here or here, right?
Mm-hmm.
So you have some visual cortex. That visual cortex is in human brain is responsible to view an image for a particular pixel. So it won't be scattered everywhere. So that is the main objective. So based on objective, they created this convolution network. So can you see this cat? So you don't see this cat backend. So you won't be seeing all these things. So where it is anything. So we'll be seeing this area and we'll be figuring out this is a cat. That's it.
Okay.
So we won't be concentrating on whole image as an one. So we'll be concentrating on a particular local receptive field, which we say as local receptive field. Okay. So based on this, we have come up with this neural networks, convolutional neural network. If it is normal neural network, what happens is so there will be a multiple hidden layer as I told. So it will keep on weight will get increased and keep on connection will get double the time. So not double, it will be a square the time. So if I have 100 neurons here and 100 neurons here, so number of connection will be 100 into 100, right?
Mm-hmm.
So there are in CNN there are two things. So first is convolution and second is pooling. So we'll see what is convolution. Okay. So in convolution, what we do is first step is so it is just like a story. Just listen. Any doubts you can ask me. So in convolution, when you say an image is there, system can't identify what is an image. So unless or otherwise you feed it in a numerical format. So an image can be converted to a numerical format by using pixel.
Oh,
So
okay.
uh, okay, so image will be each image will have if it is 28 plus 28 row size of an image. So what it says is there are 28 pixels in your width and 28 pixels in your height. Okay, so there are total pixels 28 plus 28. So that much of pixel you have.
Is this a
So
common one for all the images? 28 cross 28?
no, it
Okay,
depends.
for
So if it is
example
small,
sake, you are saying, right? Okay, okay.
yeah, for example. So if it is small size, it's 28 plus 28, kind of passport size photo. If it
Okay,
is a
okay,
big
okay.
image, so if you see this will be
Yeah,
1000
what
to
you're saying is
2000.
height and width, right? So height
Yeah,
is 28 cross 28 means height and the width of that image. Okay.
yeah, yeah. Okay. So first step what we'll do is we'll be sliding a function. So what we'll do is so it will be in a matrix. We will be sliding a matrix on this image. So how we'll be doing is we'll check this example. So this is the image 4 and you can see 28 cross 28 image, and total pixel you can see is 784 pixels.
Mm-hmm.
Okay, internally how it will be like this. So what you can say is this each image, the each cell is a pixel data. So it will be ranging from 0 to 255. 0 is 0 is bright and 255 is
So you
black.
have overall 36 pixels here, right? So 6 cross 6. Okay.
Yeah. So 0 is, it will be ranging from 0 to 255. 0 is white and 255 is black. So
Okay.
here what we done is, so here we just divided everything by 255. Okay. So so whenever there is high, so it will be ranging from 0 to 1. So that is the reason we are having 0 0.2, 0.8. Otherwise it will be ranging from 0 to 255.
Oh, okay,
Okay.
okay, okay. So does that represents different colors, point 0.2, point 0.8 and all?
It is intensity of color. So 0.2 says it has less intensity of white. It is near to white. 0.8 is near to black.
Okay.
0.9 is more black. 1 is full black. That's it. Okay. That's simple. So this 6 cos 6, I have that 36 pixel. So first thing is, in convolution we'll be having a filter. Filter is called a kernel. So kernel is of any square matrix size. So we'll be sliding this data on this convolution, on this image. So so this some tricky part. So what we'll do is, so we will have this kernel. Kernel is anything. So what we'll do is, it will be having 0 and 1. Okay. So we'll be sliding this data. So 0 is x0, 1 is 1. So what we'll do is, we can see here. So this is the data I have converted. How I converted? So you can see. So this is my data: 101, 0, 0, 10, 0, 10. So I will be taking this data and fitting up here. And what I will do is, I will do 1 into 0, 0 into 0, 0 into 0, 0 into 0.2, 1 into 0.8, 0 into 0.0. So you can see. So with this, what I will do is, so wherever it is 1, I will just add it up. So 0.2 plus 0.8. Everywhere where it is 0, it will just leave it and just made it as 1. Okay,
Can you
got it.
please repeat it if you don't mind? Can you go to the previous slide and show me that? So here, what
So
we are doing is we are applying the kernel on this data set, right? Is that what you're doing?
yeah, yes, exactly.
Is
So
this
we
what
have a
called
kernel.
as sliding window? Okay.
Yes,
So what
exactly.
is
So
kernel is
kernel,
all about? Kernel is all about?
it's a filter kind of thing. So each there are many filters which will be used for many kinds. I'll tell you that. So why this filter has been used, I'll tell you.
Okay, okay.
So it's a kind of what can I say? I can say it's a kind of weightage you are having for each matrix, and you're just multiplying with on each 3 cross 3 matrix. So sliding one by one, and
Mm-hmm.
whatever result you're aggregating it and putting it here.
Mm-hmm.
So here you can just say wherever one it is there. So you can see one is there diagonally. So 0 is there everywhere in non-diagonal data.
Mm-hmm.
So 0.8 plus 0.2 is, so it will be answer is 1. So
Mm-hmm.
next we are just sliding there. So again the answer is 0.3 plus 0.9, that is 1.2. So again you're sliding. So one
Oh,
by
okay,
one.
okay. You're adding
Okay.
these values, right? Okay.
Yeah. So
6.3,
keep on sliding.
0.9. Okay, okay, okay.
So you keep on sliding it, and your your size of the image is 6 cross 6, but here it has become 4 cross 4.
Mm-hmm.
Okay, it has been reduced, right?
Mm-hmm.
So, so see, if I say, if you have thousand plus thousand images there, so this thousand cross thousand image, if it is there and you're using deep neural networks, so the size, number of connection will keep on exploding, and your memory is going to be more intense. So here in convolution, the first step is, you'll be having kernel. That kernel will be sliding on each 3 cross 3 matrix. That is 3 cross 3 can have any matrix. So so preferably you should have a square matrix with small size.
So the
Say
dimension is
for
3 cross 3 for all the things, or it can be anything.
no, anything, you can have anything,
For
but it
this
should be a
illustration
square matrix.
purpose, you're taken 3 cross 3, right? Okay, okay, fine.
Yeah, yeah. Okay. So, as you saw, what is kernel function? The kernel function can be of many types. So each kernel function has some purpose. So, if you want to have a blurred image, you can have averaging of neighbor. So, if you have 3 cross 3 of one on each data, one on each, one. So your data, your image will become blur.
Mm-hmm.
And if you want to have only edge detection, if you want to narrow, if you want to find the edge of narrow side, so you want to make your kernel as positive on on narrow data. So let me show you this example. Yeah, we can see this. So this is my original image. If I just send this data as a kernel function, your image will become like this.
Mm-hmm.
Your image will become blurred. And
Yeah.
if you want to detect only an narrow edges, straight line edges. So here, what you will do is you will just make this uh, uh, in middle column as same data, and another data should be of negative. And if
Mm-hmm.
you want to find the vertical edges, so you'll be putting like this. So, and if you want to find the diagonal edges, that is 45-degree edges, you will put your number, any number like this. So if this number is more, so your data will become more sharpened. That edges will be more sharpened. For example, so this is my image. When I pass this 2 cross 2 like this, your output will be like this. Your horizontal edges will be captured. And if you are putting everything as -1 and only in between data as positive data, so it will be capturing both edge, horizontal edge, and horizontal and vertical edges. You can see this.
Horizontal and vertical edges. Okay.
Yeah. If if I just put this 2 cross 2 in this way, so you can see only this edges, only this vertical edges will be captured. Here, horizontal edges captured. If it is, if you assume 2 cross 2 2 2 here, it will be only straight line edges will be captured. So you
Okay.
can just check on this website. So here it will be given. So
Okay. Eye sharp.
okay,
Okay. Okay.
okay,
Yeah. To confirm that, I can come and check, change the values, and I can see, right?
yeah, you can check it out. So here how they are done.
I can change the values also, right? Okay. Fine.
Yeah, you can check.
Eye shock.
Okay,
Eye shock. Okay. Fine.
so first thing is, now I told about what is this H kernel function, how we slide this kernel function one by one. Now, if you want to, if you have a kernel size with 2 cross 2 or 3 cross 3, and if your original image is more than 3 cross 3, it is 6 cross 6 or 8 cross 8 or anything,
Mm-hmm.
what will happen is your image size will get shortened. Agree?
Can you come across?
So
Can you
here,
come back again? Yeah.
see, so this is my original image
Three
with
cross
6
three.
cross 6 data. 6 cross 6
Six cross.
this,
Yes.
this
Yes. Yes.
image.
Okay.
When I do convolution on this kernel function, my output will become 4 cross 4.
Okay. So what is
My
it
image is
actually?
getting short.
Convolution is nothing but sliding the kernel on the image size, right? Is that what convolution, right?
Yeah, convolution is convolving. You are just can you are just
Transforming.
reducing the size by using some transforming by passing some function. That's called
So
convolution.
reducing the size of my images. Am I say? Can I say
Yes,
correct that way,
by
right?
by passing some function.
Okay. Yeah,
Just like
by
in your original
passing
image.
some function here, nothing but the kernel function. By passing the kernel
Yeah,
function on the original 6 cross 6 pixels, I'm going to reduce the size of it. Am I correct?
yeah, yeah,
Okay.
exactly.
Okay.
Fine. So what happens is your image will get reduced. That is called narrow. You are just
Mm-hmm.
narrowing the data.
Mm-hmm.
This is my input. Here is
Mm-hmm.
my input. When I pass some formal function, in my input output gets reduced. That is called narrow.
Mm-hmm.
What if I want to increase the size of image? This is my image size. Example, this is my image size, and I want to increase the size just like this.
Mm-hmm.
I want to increase the size. So what can I do? What can I do is that is called widening the image, wide convolution. This is narrow convolution, it's a wide convolution. So how do you have any idea how can we do by this form, by this way, by passing the convolution kernel on a data, I want to increase my image. So I need idea how can we do?
Mm. So here we are applying the kernel function on this data set, and here we
Yeah.
are
So
increasing the dimensions, right?
yeah, say I have 6 crosses data. When I pass 3 cross data, I'm getting reduced to 4 cross 4. What if I want to increase it 6 cross 6 into 10 cross 10?
Okay, it will increase, right? Little bit increase.
Yeah, yeah.
Okay.
How? Any idea how can we do? Can you thought?
Same
Can you
0
think
and 1,
about it?
right? 0 and 1 will be applied. 6 cross 10.
Yeah, yeah. How can I increase the size? So, how can I increase my output? Okay. So the
Increase the
answer.
output.
So the answer is we'll be using zero padding.
Zero
So
padding. Okay.
what we'll do, we'll do zero padding and we'll increase size. Examples here.
Oh,
So
okay,
instead
okay,
of
okay.
this data,
To
so my
increase the
data is
dimension, you're adding
yeah,
0, right? Okay.
yeah, adding zero. I'm adding zero and
So
the
3
other thing
cross
is
3,
my
if I
data.
want to increase it to 4 cross 4, so for that particular, the vertical and horizontal, I put 0, right? Am I correct?
Kernel can be same. Kernel 3 cross 3. I'm just if I just add the zero padding, my output will be 8 cross 8. From 6 cross 6, I
Oh,
got 8 cross 8.
no,
Right?
no, 1 second. See, the kernel is remains same, 3 cross 3, but your pixel
Yeah,
is 6 cross 6. If you want to
yeah,
increase it, so you need to put additional zeros, right? For the outside
yeah.
thing, right? Okay, okay,
That is zero. That is zero padding.
okay.
And it's zero padding. My output is 8 cross 8. That is called zero padding. If you want to widen your convolution.
Mm-hmm.
So
So why do I
the
need to
same way.
widen my convolution? What am I going to get?
So in real time, so when you have some image and you want to increase the size of the image,
Uh-huh.
there are there are many online sites there. Just give this any image and what size you want. It will just automatically give you the image size what you want. So
Mm-hmm.
internally this will be done.
Oh, behind the scene, this is what is happening. Okay, 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 okay. Zero
So
padding is
okay,
done in order to give us. Okay, okay, good. Fine,
okay,
fine. Okay.
fine. So here just made this everything without blurring. They will have some certain kernel function which doesn't affect the image. Okay, image
Mm-hmm.
size,
Mm-hmm.
image quality.
Mm-hmm.
In fact, they will. In fact, you can have different kernel where your image will be more sharper. So
Mm-hmm.
so you can see some of the kernel function which will give you more sharpened data. Can just explore. So there are many such caution. There are many such kernel function. Using kernel function, you can play with that. Okay,
Mm-hmm.
fine. So now zero padding, you are clear, right?
Yes, yes. Zero padding is basically to increase the size of the image, right? Okay,
Yeah,
fine.
yeah. And one more thing is, you will be what I told you. So this will be sliding one by one. I told you, right? So this will be here. Next will be this. So it will be sliding one by one, right?
Uh-huh.
What if you want to skip the sliding with one cell? That is called stride. Okay. So
Sorry, I
if I
didn't
just
get it. What did you say? I was just
so
noting down the website, the URL which you
okay,
mentioned, right, to check that one.
okay, fine,
Yeah.
fine. So this is the data I have. This is the kernel function I told.
Yeah.
So this is my first convolution. So I'm just taking one. I will be having one, right?
Mm-hmm.
Out will be one. Next will be this will be slided to the
Zero.
next cell here, right?
Okay. Mm-hmm.
Uh, this is I'm sliding the original image with a kernel function with the stride size one.
Okay.
Okay. If I want to skip one cell over here, I want to go with another alternative cell. So
Okay.
first will be here. My second will be here from here, I'm telling. So
Okay.
that is my slide size is 1, 2.
Uh-huh.
Okay. So this all on the slide of 1.
Okay.
So
Yes,
this is
yes,
my
yes.
vertical slide of 1.
Okay. Okay.
Okay.
You're
If it
just
is 2,
moving one cell ahead, and if you
yeah.
want to do vertical, one cell down, right? Okay, fine.
Yeah. If you want to skip one, so that is stride of 2.
Okay.
Okay. So all this thing I'm telling you, this will be a hyperparameter for a convolution neural network when you do coding.
Mm-hmm.
Okay. So now see what I told. There will be number of any image you give to the machine. Machine will be converting that image to pixel.
Mm-hmm.
Say if it is 100 cross 100, if it is 100 cross 100 pixel, then your input will be 1 lakh. 1 lakh.
Mm-hmm.
Okay. have 1 lakh neurons.
Mm-hmm.
And now in normal feed forward neural network, what will happen is you will have number of hidden layers with number of neurons available.
Mm-hmm.
And this neurons with each neuron will be connected with each neurons in your second layer. And
Mm-hmm.
this neuron, each neuron is connected to each neurons is then further layer.
Mm-hmm.
So your connection is exploding like anything.
Mm-hmm.
Agree?
Yes, yes.
So if you're working with any machine learning algorithm or any classification or regression, your input x1, x2, x3, so it will be 100 or 200. That's it. You will think about. You can't think 500, 600. You won't be having that
Mm-hmm.
in real time.
Mm-hmm.
Agree. But when you take a image, the image has more details on each pixel. So your input is exploding like anything. And if you have same feed forward neural networks working on with same image, your connection will keep on exploding, and your memory will up, keep on sucking more resources.
Mm-hmm.
Agree. What is the problem? Can you visualize what is the problem?
Yeah. So it'll exploded with it'll consume too much of memory, and the
Yeah,
entire system will come to an halt, right? Grinding halt. Yeah.
yeah. So you need to have such a
Pixel image.
supercomputer to train a simple image also,
Mm-hmm.
right? So example, 100 to 100 pixel is there. So your input will be 10,000 neurons, and interconnection first interconnection will be 10,000 to 10,000. That is it's going on, and if you
Okay.
on keep on having more number of layers, it will keep on increase. So number of parameter getting increases.
What is the
So the
zero within the bracket? Zero within the bracket. What is the zero function?
it is called order of rotation. So
Okay. Okay.
might have order of
Okay. Okay. So the order of magnitude kind
base.
of thing, right? Okay. Okay.
Mm, yeah. So how the order is getting increasing in
Oh,
interconnections. So
interconnections, right? Okay, okay. So each and
you might
every
have
layer, it will get exploded like anything, right? So 10, 100, 10,000 into 10,000, again 10,000 into 10,000 into 10,000 into 10,000. Am I correct? 100
yeah.
million to train neural network. Yes.
So yeah. So that's the main problem we are going for convolution. Now
Okay.
in convolution, what we do, we just perceive with some data, and we just keep on decreasing the size of the image. We are
Mm-hmm.
not concentrating on each pixel. We
Mm-hmm.
are just taking the aggregation of some pixel by using kernel,
Mm-hmm.
and keep reducing the size of the image, and further reducing something. So our our memory is getting reduced and our connection getting reduced.
Mm-hmm.
Okay. So
Because of the kernel function, it is getting reduced. Am I correct?
by using kernel function, we are moving this kernel function one by one and reducing the size of the image.
Yeah.
Okay. Yeah,
But
that's what
connections, how it's
that's what
getting reduced because of the reduction in size. Am I correct?
yeah, yeah.
Okay.
Okay. So we are just concentrated on some local receptive. We are not concentrated on whole image. That's the main idea behind foundational network. So what we'll do is, this is my pixel, this is my data, and with pixel data, what I do on this each data, I'm just doing this passing kernel function to form a feature map.
Mm-hmm.
So this is a feature map what we got.
Mm-hmm.
Okay. So the pixel is a feature map. So each feature map now each feature map is the data inside each feature map is a neuron actually.
Mm-hmm.
Okay. So now what we do is, so this is a kernel, and with this kernel, when I apply this kernel function on this pixel, I get a single neuron in a feature map.
Mm-hmm.
So just understand this term. So this is a feature map. Feature map has many neurons, and each neuron is formed by uh, kernel applying the kernel function on my pixel.
Mm-hmm. Yes, applying the kernel function, right, on the
Ah,
feature map.
pixel,
Okay.
my
Pixel.
image. So we'll be stacking many kernel function. So what we do is, so this is a single feature map,
Okay.
single feature map. So in for efficient uh, image classification, this convolution kernel, what they are recommending is have have many kernels in, instead of having a single, have many kernels of small size instead of having a big kernel function of one size or
Uh-huh.
less size. Okay.
Okay.
have many small kernel size instead of having a one big kernel size.
Okay,
So
okay.
this will give you more information than this giving you information.
Okay, what you're saying is the small one or bigger one? Small one, right?
Yeah, prefer smaller one than bigger one,
Okay.
and prefer smaller one with many kernels.
Okay,
Okay,
okay.
so that what they are saying is instead of having a single feature map, you
Oh,
can
good.
have multiple feature maps to form a convolution layer.
Okay.
So this is a horizontal filter, vertical filter, what it does,
Mm-hmm.
we know, right?
Mm-hmm.
So,
Mm-hmm.
so here what they are doing, this is a single feature map, and this is a many feature map. So
Mm-hmm.
many feature map form a convolution layer.
Mm-hmm.
You have a you have a small kernel function of many size, and it will form a convolution layer with many feature maps. This is
Mm-hmm.
called convolution layer.
Okay.
Okay. The second part is, so you can have many convolution layer. So this is one convolution layer. This you can have another convolution layer with different kernel function.
Mm-hmm.
That's up to you.
Mm-hmm.
Okay. Okay. So this is my feature map. One feature map, many feature maps from a convolution layer, and a group of many convolution layer from a CNN, convolution
Mm-hmm.
neural network.
Mm-hmm.
Okay. So if it is RGB, so here here whatever I told you, I showed you that's a black and white layer.
Mm-hmm.
It will be ranging from 0 to 20, I told. Means, so it will have a single, it will have 3 cross 3 matrix. What will happen is each pixel will be showing, having the data about RGB. R will be ranging from 0 to 255, G will be ranging from 0 to 55, and B will be ranging from 0 to 55. So it will be like this. Okay.
So what is the RGB channels? What is RGB? It's a pixel thing, right?
Yeah, if you take any color image, the color image, if it is black and white, it will be black or white. That's it, right?
Yeah,
No other color.
correct.
But if it is a color image will have different colors. It will have white,
Correct,
it will
correct,
have black
correct. Okay.
color.
Uh-huh.
So how they identify is on each pixel will be having the combination of R, G, B. R is red, G is green, B is blue. How much red intensity it has, how much green intensity it has, and how much blue intensity it has. So
But
combination of
apart
all
from
these
that, we have some other colors, right?
no, this RGB will uh, combination of all these three can form another color.
Oh, okay. All the seven colors will be formed with the combination of these three itself, right? Is that what you're saying?
Yeah,
Okay, okay. Okay.
yeah,
But
yeah.
white will not come here, right? So RGB, white, how will you get white? Red,
It
green,
will be
green, black. Hmm?
it will be so combination of all these three. That's the
Okay.
thumb rule. That's a thumb rule. So
Mm-hmm.
all three color can form any other color.
Okay, okay, okay. Okay, okay, okay. But each one is
Fine.
0 to
So
25, right? You're saying
again, yeah, again 0 to 55.
255.
So
Okay.
it will be again like this. So again, I will do a kernel function of all these three and form a convolution layer. That's same principle.
Okay, okay.
Okay.
Feature map and all things. Okay.
So again, same principle. It's the same principle. So now the second step is pooling. So now I did a kernel function on all the data, and after putting kernel function, I got a feature map, and the combination of feature maps form a convolution layer. Combination of convolution layer form a convolution neural networks. Okay,
Yes,
till
yes.
now clear, right?
Yes,
Now
yes, yes.
second step is pooling. So
Mm-hmm.
pooling, what we do is after getting a convolution result, you see this convolution result, right? So this
Mm-hmm.
is a convolution result. But
Mm-hmm.
now pooling, what we do is again we have a kernel size of pooling, and we'll be again sliding one by one to form a max pooling. So there
Mm-hmm.
are many poolings. So there's max pooling, min pooling, aggregate pooling, anything, many things are there. So
Mm-hmm.
what is max pooling is? So you will just stride this data 2 cross 2 here. So first 2 cross 2 here, and you
Mm-hmm.
will take what is the maximum data.
0 and 1 will be there, right? 0 and 1 will be there. And 1,
No,
1
no,
will add. Yeah.
no. From here 2 cross 2. So
Okay.
if it is, can you see my cursor here?
Yes, 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 I can see.
Yeah. So this is my 2 cross 2. First 2 cross 2.
Uh-huh.
Tell me which is the highest data here, highest pixel.
Highest pixel is 0.8, point 0.9, right?
First is 0.9, max is 0.9.
Yeah, max is 0.9, correct.
I'll put it here
Point 0.9. Okay, 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 okay.
And here
Similarly,
here is
okay, okay. Here zero
here is
point 0.8
zero
is the
point.
maximum. Yes.
Yeah.
Next one is zero
Here
point
I'm
0.8, point 0.9.
yeah,
Correct. Got it.
I'm using max 2 cross 2 filter with stride 2. I'm taking stride 2 so that I'm skipping this
Oh.
one and this. So I got the data to be like this.
No, no. Which one you're skipping? Stride to in the sense, which
Stride
one?
2 means so on this one is first result.
Yeah.
Actually, if it's stride 1, I should take this like this, right? 0 0.8, 0 0.3, 0 0.9, 0 0.3, right?
No,
I'm
stride
taking
one
that.
is 0.22, 0.8, 0.3, right? For first three cells.
Yeah, yeah.
Okay.
First two. This four is first stride. This is second. But I'm using stride 2, so I'm skipping this and taking this one.
Oh, that one
So
only
this
you're
is
taking, right? Okay.
so 0 0.9. So you can see. So you can see from this data, highest number is 0 0.9, and from
Okay.
this 0 0.8, from this
Okay, okay,
0
okay, okay.
0.8, and from this 0 0.3.
Okay, fine.
So from convolution from my original image, I have a convolution layer, and from this I'm doing max pooling.
Mm-hmm.
So advantage of using max pooling is I'm reducing the memory usage, and I reduce the overfitting here. Okay,
But if I wanted to, it'll reduce the quality of the image, right?
uh, you can say that's what I'm sharing. You can't say we are not. We don't want the image as such. I just want the image. I want some information for image. From that information, what can I infer? From what I'm training the data.
Oh, what
That's
we
what
are
I.
saying, the whole idea is given that picture, I want to take a specific image, right? Specific portion of the image, I want to process it. Is that what the whole objective?
Uh, we want we are processing everything, but we are just concerned about where more intensity is there.
Okay.
Second, second thing is we are giving a result. What is the result? So I'm telling this is an image. Learn accordingly. This is a cat image. I'm telling.
Okay.
So it will figure out and tell it will for this particular output. This image should be a cat. It will identify that. That's it. It
Mm-hmm.
will have an it will have an internal equation for a particular image to become a cat on this way of
Mm-hmm.
image. It will identify and it will give you the result accordingly.
Mm-hmm. Mm-hmm.
See, so now pooling is done. So now we'll see what is. So we'll go. What is the convolutional architecture as such?
Mm-hmm.
So any image is given. You do convolution. You do pooling. Again, you do convolution. There will be many convolution you can do
Mm-hmm.
as much as you want.
Mm-hmm.
On each convolution you'll be having activation function.
Mm-hmm.
You know activation function, right? There are
Yes,
some
yes.
activation functions.
Yeah.
So you'll be using ReLU. So
Okay, okay.
after convolution, ReLU.
Rectified. Oh, okay, okay. Linear unit. Okay, yeah.
Yeah, you'll be using ReLU. So
Okay.
this is the first step of convolution CNN architecture. After this, you'll be passing this data into a feed forward neural network.
Mm-hmm.
So this is my convention. This is a feed forward neural networks. So feed forward can be again a fully connected data with a ReLU, again fully connected ReLU. How much ever deeper you want, you can just keep
Mm-hmm.
on building it. So here what you see is given an image after this convolution neural network output will be very lesser.
Mm-hmm.
Agree?
Yeah.
From this less image, you're learning this data. You're
Okay.
learning about this image. Instead
Okay.
of having 100 cross 100 pixel, here your output will be same 10 here 20 neurons.
Uh-huh.
So from 20, we're just learning this data. That's the idea behind convolutional neural network. So
Okay.
after all this feed forward, we'll be using softmax prediction for any classification problem. So softmax again it's a activation function for predicting any binary output or any multinomial output.
So ReLU
So
is used for the hidden layer or output layer?
ReLU is really used for a hidden layer.
Hidden only, right? So softmax for the output layer, right?
For yeah, for output layer.
Okay.
So, so it will be if you have uh, 10 output, that is you have 10 classification range from 0 to 9. So you'll be having 10 neurons, right?
Yeah.
In that 10 neurons, whichever is greater, it will predict that particular neurons. That's what softmax will do.
Okay. Okay. Okay.
They
Okay.
have 0 to 9. So whichever is more probability, it will predict that is one. otherwise zero.
Okay, okay. So can't we use convolutional neural network for predicting the default credit card default or something like that?
Convolution, come again?
No, can't we use the convolutional neural network for
Yeah.
predicting the defaulters? Let's credit card customers are there. Can't I use them for? But here it's again predicting the zeros and ones, right?
No, convolution neural networks is good for image. So what it does is you can predict. You can't. No one is going to stop you. But convolution neural networks has been researched and it has been good, proved for image classification and image recognition thing.
Okay.
So it is not good for any normal uh,
Machine learning
normal
algorithms, right? Okay, okay, okay.
machine learning. It is good for images.
Okay. Correct, because it's
Okay.
reduced the size of the images and all, right? So in that case, this is the best one. Okay, okay, good,
Yeah.
good. Okay, okay.
Your, your data might lost if you are using the same convolution neural network. So if you
Oh,
are not
correct, 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 correct.
okay. So it's first thing is this is the first data, first layer, second pooling. Again you're doing convolution, again pooling. Then your data, sorry, then you have again convolution network with followed by uh, feed forward networks. That's a CNN architecture.
Mm-hmm.
Okay. And with this CNN is done. So do you want me to show any uh, code?
Yeah, if you can show me the code, that would be helpful. Yeah. So you're using TensorFlow, right? So
Yeah. So for do you want me to show with Keras or normal TensorFlow?
normal TensorFlow is okay for me at this moment. Yeah.
See, normal TensorFlow is kind of tricky for you to learn. So for basically,
Oh, really?
so yeah, so you need to do many things with normal TensorFlow. It's a
So
vanilla TensorFlow.
yeah, I installed TensorFlow in my Windows. It's throwing a lot of error. Mm.
Yeah, Windows. What you need to do is you
I'm
get
using
your Python.
2.7. 2.7 is okay, or 3.6 is the
Yeah,
best one.
no, with Windows 3.6 won't work for TensorFlow. It should go for 3.5.
Uh
For
huh.
2.7 also, it should work 3.7, 2.7.
2.7 it should work, right? Okay.
Yeah, it should work.
But I was posing a lot of error. Okay, fine. Yeah, go ahead. Go ahead. Sorry.
Yeah, so for TensorFlow, so you just need to have this function to be imported, this module to be imported,
Mm-hmm.
import TensorFlow, and we are working on MNIST data,
Mm-hmm.
the default data available. So what it has is it is having the handwritten
Images, right?
image,
MNIST is that it has the repository of the images, right?
yeah, handwritten number image,
Okay.
ranging from 0 to 9.
Uh-huh.
So you want to predict that. So handwritten. So this is our input. So
Okay.
one input, so input. So now, fine, we'll build a convolutional neural network using TensorFlow. So this is a vanilla TensorFlow. I'm not sure if you are how comfortable are you in Python.
I'm comfortable in Python, but this TensorFlow I'm quite new.
Fine. So again, everything is function whatever they have
Oh,
done.
functionally, right? Okay, okay. If you remember the
So
argument, that's it, right? The feature maps,
yeah,
kernel size, and
yeah. So these are convolutional networks, and this is the input I'm passing. And with filter, so what is the size of the filter? I'm telling this is the size of the filter. Uh, So number of feature map one, I want 64 feature map, and kernel size is 3. It's 3 cross
okay.
3. You can see that. And or the stride, I'm telling stride as 2, and convolution pad as same. So same means so I want there are two argument for this. The same you can either increase or either you can increase the size or same size. So
Mm-hmm.
same means I won't be having the padding. That's
Mm-hmm.
it. No padding. No padding.
Mm-hmm.
And I'm using tensor. I'm using the redo function, redo
Mm-hmm.
activation function.
Mm-hmm.
So this is the first convolution layer, and this is the second convolution layer, and followed by pooling.
Mm-hmm.
Pooling I'm having. So my input for pooling is this one,
Mm-hmm.
and This is the size of my pooling and stride what I'm asking for, and it's a values. So I don't want any padding.
Mm-hmm.
Okay. So after that, after pooling, I'm going to reshape. Why reshape is, so here I told you. Yeah. So after pulling your data will be like this, right? So
Mm-hmm.
I want this to be input for the feed forward neural network. So I'm reshaping it to a normal NumPy data. So I'm just
Mm-hmm.
reshaping this data to so normal NumPy data, and after that I'm taking this to a dense layer, dense
Mm-hmm.
feed forward neural network with this input as this one and fully connected layer. How many fully connected layer? I'm taking a 64 fully connected layer with 64 neurons for each deep layer and taking this as a ReLU function.
Mm-hmm.
And again, I'm passing it to a this is a software function.
Mm-hmm.
Software function will give you a result. Okay, so this is a prediction function. How to build? So I'm just build CNN by just calling
So you
this one.
don't have any predict function? Predict function is not there, right?
It is there. So predict functions written below. Okay,
Okay.
I'm just argmax. Sorry, this will be a softmax function. So this is normal dense function.
Uh-huh.
This is a softmax function. After this, I'm predicting it.
What is dense
So
function does? What it does? The dense function?
dense is convolution. What is it? Dense feed forward network. This one.
Oh, just a feed forward network, right?
Yeah, this dense feed forward layer. This one.
Okay, okay, okay.
Okay.
No, the feed forward layer and dense feed forward, both of them are same, isn't it?
For us, it is same. In coding, we use dense as a feed forward network.
Okay.
Okay. Fine. So this is a prediction function. So I'm just training this using Adam optimizer as an so it's a kind of optimizer for training the data.
Okay.
And after that, prediction is so prediction. So this is the training. So I'm training for each this for each step, each
Mm-hmm.
epoch, and see number of epochs I'm running. And here I'm evaluating the result.
No, tell me
And
one thing. How do we determine the optimal number of epochs? Because if I blindly give some number, based on different number, I can get different output.
yeah, see,
Again, the
you need
learning
to
rate, how do we determine the
got
optimal
it.
number, all the things,
Yeah,
right?
I got it. I got it. Anything in machine learning and neural networks, the parameter whatever you pass, it's a trial and error. You need to find on your own. So that's the single thing we need to do it. So otherwise, code is there, everything is there. You just need to pass it and find it. But here, number of batch size you want to do, number of iteration you want to
No, do
pass,
I need to
what is
use
the
grid search?
configuration.
And grid search is available here.
Yeah, research you can do. So research is available everywhere. You can just do
Yeah,
it, provided if you have a good number of resources
because if
available.
I use grid search CV cross validation, it gives automatically the best params, right?
Yes, exactly. So, but it will take time, and you should have a good resource also.
But again,
See
if
now
you
I
do
have
it, if you keep changing the values manually, it will take a lot of time, right? Grid
yeah.
search is the
Again,
best one. Am I correct? Even TensorFlow also, it is available. It should be available.
yeah, yeah, it should be available. Yeah, it's the best thing to do, provided you have a good resources and you have more number of time to do it.
Mm-hmm.
That's it.
Okay, okay.
Right. Now I showed you using TensorFlow. Right. Now there is another function, another plugin called Keras. Keras is a Python library which which is built on top of TensorFlow.
Mm-hmm.
Okay. What it does is it makes your code easier to write. So we just
No,
give
Keras is for Theano, right? With the Theano background
both.
only, it will work, right?
You can use both Theano and TensorFlow. Anything you can
Oh,
do. So if you want to use TensorFlow, you can go to backend. There's some JSON file. You need to just update the JSON file to become a
okay,
TensorFlow.
okay, okay. Yeah, good.
Okay.
Okay.
So here I'm using the TensorFlow backend. If you are using backend as a TensorFlow, automatically just change TensorFlow.
Okay.
Here we can see it's very easy to write and very fun to write also.
Hmm.
So there I just showed you very big code. Here it's simple. So this is a model sequential. There is one by one I need to do it. So this is my first layer. First layer is my convolution layer, convolution 2D layer with 32 input and kernel size this one, and activation value and input shape is this one. The shape I need to give. And second layer is again a convolution layer with input this and kernel size and activation size. The third is max pooling with stride size with spool size of 2 comma 2 and dropout. So dropout is used for to avoid overfitting. So I'm telling 0.25% you need to drop out this data.
Hmm.
So that it will avoid overfitting and flatten. So there I just reshape the data. So I told you if it is 2 cross 2, reshape it to an up by series. The same way to just flatten the data. So this flattened data will be given to a fully dense neural network. So here dense neural network with 128 neurons and activation value and again dropout and again dense function. Again dense function with output as max. So this will begin output. So here you are aware of it and you are predicting it. So I'm using TensorFlow backend. So output is this. So it's very easy to write using TensorFlow.
Hmm.
Okay, fine. You got it? Any doubts till now?
Yeah, if you have any note for each and everything, right? That Kiros, what function is for comments, if you could have put it, that will be helpful, right? So which one is for which one? Yeah. So here you put convert and all. For example, just scroll down there, the Kiros or something like
Uh, yeah, got it. Let me check another file where I have written or not.
that. Yeah. So can I get access for this folder, which you have it, right?
Yeah,
So I can download the code
yeah,
and try it out, right? Okay.
this is my personal GitHub. You can just this is publicly available. You can take this.
You need to give
Yeah, here I
access to
have
me or what? Nothing, right?
no need. It's a
Okay. Okay.
publicly available. You can
Okay.
just
Okay.
take it. So here I would have given the comments. You can check it out.
Oh, comments are the right. So train them. Fine. 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 What's the file name? Just go up. Let me note it down. Okay. Building. This
So
one.
this
Okay.
one
Okay.
can
Okay. Okay. So whom do you work for, Mohammed, currently?
I work for Logitech.
Okay. So you do a lot of image processing there.
Image processing, not here right now. So here
Okay.
mostly I work in text classification,
Okay. Okay.
NLP. Right now using NLP, but in later on we do have projects to come up in working with images and videos.
Okay.
But
Okay.
I used to take classes, so I need to be updated in everything.
Okay. Okay.
That's it.
Okay. Fine, this is good. So what I'll do is I just noted down this repository name. I'll go and download this one. How about the PowerPoint thing, the slide which you show, right? For me to recollect everything, I need to go through on it. And see,
Slide
tonight I'm
also.
traveling to my native because my wife is expecting. And thing is, Monday we can come. We'll circle back, right? So in order to have any questions, something, right? One more review session.
Yeah, sure,
And
sure.
again,
See,
so after convolutional recurrent, you said, right? RNN.
yeah.
Okay.
See, in deep learning, you can go to this website. Or go to my. This is my.
Okay, okay. NRS, I noted down. Okay, fine. NRS noise and deep learning, right? Okay,
This is my local repository,
okay.
and in that you can go for repositories in deep learning,
Uh-huh.
and in that deep learning you can go for content here.
Content.
In
Okay.
you can see CNN dot
CNN.pd.
TensorFlow and CNN.pdf.
Okay,
So
fine.
that's the PDF I told you.
Okay, okay.
Okay, fine.
All right. Thanks.
So I will just give you a short note in RNN as well.
Okay.
So till now you understood about the image, what it does, how we are just doing this classification or how we doing
See,
image
what was the
processing or
final output? I did not notice that one. In conventional, finally, what would we use the number image.
yeah, output will be 0 to 1, 0 to 9 ranging from, so you can see here, right?
So here we are giving 0 to 9 related
No.
images
See,
as
what
in.
we'll do is we'll be giving the image and target also will give. So see here. So this is my image 5
Mm-hmm, mm-hmm,
and the output is 5.
mm-hmm,
This is the image output is 0.
mm-hmm,
Then output is 4.
mm-hmm.
So this image I'm feeding to the neural networks to learn by itself. Any
Now
number like
go
this
to
given to
9. 9 is class 9, right? So it is 9. So what it does
yeah
is any image, if I get, it will tell me whether it is 9 or 8. That's the thing it
yeah
will give, right?
exactly. So you
Okay,
can see what I have predicted. So this is my prediction. Uh,
okay.
this is a prediction. So 7 when
So
I
what are
give
my understanding here is, let's say if I give images like a cat and camel and elephant, the predicted
Mhm.
output will be like that, right? So this is cat, this is elephant.
You need to teach that. So what is the target you are passing? If you show cat and give a target data as cat, it will keep on learn the data as a cat.
Mm-hmm.
Here I'm just having only 10 output 0 to 9. See, this is the prediction data. So what happened is, so this is my data I have passed on. Actual is
Correct. So
2, but I
irrespective
predicted
of number two, the image which has two, right? Different patterns in it, right? So two is there,
yeah
and other one is something called sliding two, right?
yeah.
Still, okay.
Actually output is 2, but I predicted as 3 here. It's
Uh-huh.
wrong actually.
Correct,
Right here
correct.
it is 4, but I predicted as 6 because
Yeah.
it looks like 6 okay. So here it is 8, but I predicted as 2.
So how did you correct this? Any idea?
We need to correct this. We need to. So we are getting accuracy of how
Okay,
many accuracy? I'm getting accuracy of like 67%.
okay. Just seven
If I
only,
want
right?
to,
Okay, yeah.
if I want to increase the accuracy, I need to do more epochs. I just done only 4 epochs. It will
Okay, okay.
take time again. For
Correct,
that
correct,
purpose,
correct.
I just did only
Yeah,
four
yeah,
epochs.
yeah.
So usually in real time, we'll be doing 1,000 epochs, 500 epochs will do.
Okay.
So if you do more epochs, you can do this one as a
Mm-hmm.
homework.
Okay.
Take this and try to do more epochs and increase the result, increase the accuracy.
Okay, okay, fine.
Okay.
And okay, okay. Mohammed, so it's already getting late for me. Is there any way if we can carry forward RN on Monday? Right?
Yeah. Fine.
That's all right. Yeah, fine. Because I need to go to the station and I need to pack up things before that. Okay, fine.
Okay. Fine. So
Right.
even I need to break my fast.
Oh, yeah. Sorry. You're already on fast, right? It's extremely sorry. You guys don't eat anything full day.
Yeah. Yeah.
So even night
Full
you
day.
don't eat.
No. It will start from before sunset and sorry, before sunrise, and we'll be ending the fast after sunset.
Okay, okay, okay. Before sunrise you can eat, and after sunset you can eat anything, right? Okay.
Yes.
I think they give
Exactly.
porridge for you people, right? So in the mosque. Okay.
Come again.
Porridge. They give porridge. Kanji, kanji.
Yeah.
Aye.
Yeah. Fine. Thanks,
Okay. Thanks for
Raj.
your time, and please send me your account details. I'll do the transfer. Okay. Right.
Yeah,
I'll do
sure.
it tomorrow morning. Don't get me wrong. Okay. Tomorrow I'll definitely do it.
Yeah,
Okay. Fine.
sure.
All right.
Thanks.
Thank you. Thanks a lot. Thanks for your time.
Raja,
Yeah.
do you have Tez account? Tez?
What is it?
Do you have Tez app? TZ.
What is Tezaba?
TZ, Tez.
TZ. No. What is that? Tez.
It's an app, Google app for transferring on a delivery.
No, I have something called Phone P, Phone P. That is also much faster,
Oh,
very easy. I'm comfortable with that.
okay, phone pay also you can you transfer with using phone number?
No, no, no. With account details, phone number I can do it, but I don't know how far. Let me give it a try with phone number and see. If possible, I will do that. I will just initially transfer 100 or 50 bucks. Okay, and if
Yeah,
you
even I
confirm,
have
then I
phone.
will. Yeah, fine. If I don't get that one right, I will probably try with test as you suggested. Okay.
Yeah, Tez is very easy. So using phone number you can just transfer.
Okay, okay, great, great. So your number is tied with test, right? The account number. The
Yeah,
mobile number
yeah,
is tied with the proper account number, right? Okay, fine.
yes.
Then it's good. Okay,
Even I
fine.
have phone pay. Try it out. If it is not working, you can just get
Sure,
the
sure, sure.
Tez.
I'll do that. I'll do that.
Raja.
So
So
okay,
I hope it's useful for you.
okay, go and have it's sunsetted already. Go and have something. Okay, bye.
Yeah, I hope it was useful for you.
Yeah, definitely, definitely. It was helpful. Thank you. Thanks a lot. Yeah.
Thank
Bye. Yeah.
you.